Good morning, everyone. Thanks for joining us today for our monthly webinar. And it's my pleasure to introduce Dr. Augustine Obour. As many of you know, Augustine was my former PhD student. I just want to give a little bit of introduction. Augustine is currently a professor in soil science at Kansas State University. He's originally from Ghana. He got his his bachelor's degree in crop science from in a university in Ghana. I'm not gonna try to pronounce the name of your university, Augustine, sorry. Then he moved to the US for his master's. He completed both his master's in agronomy, PhD in soil science, and both his thesis work and his dissertation work were conducted here on. So he's a offspring of the research center. And then he continuing his career. Right now, as I mentioned, he's at Kansas State, and his research is mainly focused on drylands, and I think that's dryland cropping system. That's what he's going to be talking to us today. Augustine is very active both nationally and internationally. I think he just returned from Africa, from a trip to Africa, so he has a very strong international program in West Africa, where he's helping with farmers with sustainable intensification of different agriculture systems. In the US, he's very active with the tri-societies. That's, for those who don't know, that's Agronomy, Crop Science, and Soil Science Society of America. He's chair and co-chair numerous committees, including he's currently the chair of the ASA Global Agronomy Soil Section. And like I mentioned, he also served on numerous other committees associated with the tri-societies. He's also associate editor for Agronomy Journal and Frontiers in Plant Sciences. So it's, again, my pleasure to introduce Dr. Augustine Obour. Thank you, Augustine, for accepting our invitation again. The floor is all yours. Thank you.
Yeah, thank you very much, Maria, for the introduction. Can you hear me? All right. Thank you, Dr. Severia. And like Dr. Severia mentioned, I'm the first PhD student of her program. And the training that I had in ONA has been very, very useful for me in my success as my current program. My research is mostly focused on dryland cropping systems, looking at soil and nutrient management, basically in wheat and grain sorghum. And because of the training that I had in ONA, I've also added forages in my cropping systems. So the training that I had from ONA has been very useful to me in my program. Today, I would like to share with you some of the work that we've been doing, looking at grazing, cover crops, and annual forages to improve soil health in dryland cropping systems in the semi-arid US Great Plains. So before I get started, I would like to talk a little bit about our production systems that we have in here. Water is very important for our farming systems in the US Great Plains. This is a map of the US. The dark outline is the US Great Plains. We have a precipitation gradient from east to west. So when you go to the eastern part of the state, we get more rainfall. For instance, in Manhattan, we get in about 40 inches of annual precipitation. But when you go to the western part of the state, where I'm located, precipitation is about 20 inches of rainfall per year. So depending on how much rainfall you get, the cropping systems are different. So you go to the east, they grow more continuous corn or corn soybean rotation. Here we do have a lot of small grain crops like winter wheat, and then we grow sorghum and sometimes corn. And we also have a lot of livestock. Nevertheless, since even though we are dry, we are more important grain production region. We produce about 60% of all wheat produced in the US. So the Great Plains account for about 60% of winter wheat production in the US. We also grow about 96% of all sorghum. And Kansas is #1 in wheat and also sorghum production in the US. So our production system here has some form of fallow, because the fallow is used to store water that helps to grow the next crop. So in areas where we have less than 18 inches of precipitation, we do have wheat sorghum or wheat sorghum fallow or wheat fallow rotation. So we plant winter wheat in October, harvested in June, and then we have about 14 months fallow period in the wheat fallow rotation. In a wheat sorghum fallow rotation or wheat corn fallow rotation, we grow 2 crops in 3 years. So we grow winter wheat, October harvest is in June. We have a fallow period from June through May, and then we grow grain sorghum. So the fallow is used to store water that helps to stabilize crop yields. The challenge we have is controlling weeds during fallow. In some of our cropping systems, we use tillage to control weeds, and doing so decreases the amount of residue cover, which exposes the soil to erosion. Even under no-till situations, in years that we have prolonged drought, we tend to have less residue, and that exposes these fields to soil degradation. So in our environment, protecting the soil is very important. And one of the things that we can do is to grow cover crops. If you plant cover crops, they provide residue to protect the soil against wind erosion. Cover crop can also increase the amount of residue to improve soil structure and soil organic carbon content. It can also help in weed suppression. However, cover crop is a crop. If you grow a crop, it uses water, and in water limited environments, water is important. If you use it in growing a cover crop, it impacts the subsequent crop yields, particularly in dry years. So we have some research in Garden City done by Dr. Holman that showed that when you grow a cover crop ahead of a crop in a wet year, we don't see any impact. However, in dry years like 2012, growing a cover crop ahead of a winter wheat crop resulted in about 30 to 70% yield reduction. So how do we make good use of cover crops in our environment? Because we need to protect the soil. We have seen that most of the cover crop species are actually annual forages, so they have good forage production potential. So if we graze these cover crops as a forage resource, we can get some economic benefit from growing these cover crops. However, if you do that, what are some of the drawbacks? Some may include you are grazing the cover crop, so you're reducing the residue amount, which will expose the soil to erosion, which we really want to prevent. And then grazing can also cause soil compaction and decrease water infiltration. If you graze the cover crop, remove the residue, it can also impact soil organic carbon accretion in these soils. So since 2015, we have been looking at how we can utilize these cover crops as a forage resource. So one of the things that we are trying to answer is to look at what is the productivity of these cover crops? How much forage production potential does these cover crops have? Then we are also looking at the impacts of grazing these cover crops on the subsequent crop yields and also weed suppression. And finally, we are trying to quantify the impacts of grazing cover crops on soil health and also the overall cropping system profitability. So we are doing this across Western Kansas, trying to capture the precipitation gradient across the state. So we are concentrated on the western part of the state. We are looking at areas that has about 26 to 28 inches of rainfall. That would be central part of Kansas. And then most of our research is located in the west central part of the state. And then we go all the way to the southwest Kansas, where we have about 16 inches of annual precipitation. So we're trying to see how these cover crops will fit into our cropping systems across the state, especially in the western part of the state. So how do we fit the cover crops in our production system? So this pie chart shows the wheat sorghum fallow rotation, or it can be wheat corn fallow rotation. So we grow winter wheat, we harvest the wheat, and we have a fallow period before grain sorghum is planted or corn is planted. So what we can do, we can plant a cool season cover crop after corn harvest or after sorghum harvest. And then we graze the cover crop, we terminate it and plant the next wheat crop. Or we can grow a cool season cover crop in the fall after winter wheat harvest, sometime in September. We terminate these cover crops and then plant grain sorghum or corn the following year. Or we can grow a warm season cover crop right after winter wheat harvest. We graze the cover crop or terminate it and plant grain sorghum the next year or corn the next year. So this is how we are fitting the cover crops into our cropping systems. We have producers that we are working with that are planting corn. So they grow corn and plant cover crop after corn harvest, and the following year they plant the field to corn too. But here, the most dominant production is the wheat sorghum fallow production system. So that is what I'm showing here. So in terms of experiments, we have an experiment at K-State HB Ranch. Kansas State University has a ranch at Trigo County. So that is where we have our cover crop grazing experiments. Here we're doing it a wheat sorghum fallow rotation. We have 5 treatments. The chem fallow is our check, that is the dominant crop production system. Then we have cover crops that we are not grazing, that is a standing cover crop treatment. Then we have hay cover crop treatments, and the cover crops we are grazing. And then we have a flex cover cropping treatment where we plant the cover crop when the soil moisture conditions are good. At the beginning of the spring in March, we take water content measurements. If we have adequate water in the soil, we plant the cover crop. Otherwise, the field is left as fallow. Then we are haying the cover crops at the time of the oat and triticale heading, and we hay it about 6 inches tall, so we leave a little bit of residue on the soil surface. We're grazing these cover crops using heifers. The stocking rate is about 1,200 to 1,300 pounds live weight per acre. Here we are only doing mob grazing, so we use panels. Our plots are about 60 feet wide by 100 feet long. So we use the panels, fence the plots, and then we stock the field based on the available forage. We are trying to graze about 40 to 50% of the available forage, and then we move it to the next plot. We are not measuring weight gain. We just want to see the impact on the soil and crop yields. So this figure here is from our HB ranch study looking at cover crop productivity over 8-year period. The blue bars are the standing cover crop biomass. The red bars are the pre-grazing biomass, and the green bars are post-graze cover crop biomass. And the purple bar is the hay cover crop treatment. As you can see from here, productivity varies across the year, and this is reflecting on the amount of precipitation we receive and also soil temperature. So when we started in 2015 through 2018, we were producing about 3,000 to about 4,000 pounds per acre. Then we hit a dry cycle in 2019 to 2022. Now we are in drought, and the productivity is relatively low. We're getting about 2,000 pounds per acre. On average, if you hay in the cover crop, we are removing about 70% of the available cover crop biomass. But when we graze it, it's roughly about 40 to 50% of the available biomass that we produce. So what is the impact on cover crops on the subsequent winter wheat crop yields? Here we're showing data that we have from 2016 to 2022. The bars here, the dark bar is the fallow treatment, which is the check. The light gray bar is the graze treatment. The orange bars are the standing cover crop treatments, and the green bars are the hay treatments. The blue bars represent the flex cover crop treatment. When we look at the yields over the years, we saw that in 2016, we did not see the cover crop impact on the subsequent winter wheat yields. However, in 2017 and 2018, growing a cover crop ahead of the grain crop resulted in a significant yield reduction. However, in 2020, 2022, and 2021, we did not see an impact on crop yields. Interestingly, in 2021, cover crops increased winter wheat yields compared to the fallow. On average, though, when you average across the 7 years, there was no significant differences between the cover crop treatments and then the fallow treatment. So this is interesting. So when we graze the cover crops or we hay the cover crop, yields were not different from the standing cover crop. And it was also not different from the chem fallow, which is a very good news for our producers. Then we also look at grain sorghum yields as affected by cover crops. Here again, the same bars. We did not see any difference between the cover crop treatments, whether we hayed or we grazed it. Grain sorghum yields were unaffected compared to the standing cover crop, and even the fallow treatment was not different from our cover crop treatments. So we look at the profitability of the cropping system. Here, profitability was calculated based on revenue from the grain crops and also the variable costs. So if you look at revenue side, we are looking at wheat yields and sorghum yields from the chem fallow, and then the cover crop standing treatments. However, if you hay the cover crop, then you are getting some revenue from the sale of the hay, which is about $123 per acre. For the grains cover crop treatment, we are only using half of the available forage, which is about 1,175 pounds per acre. And then we are estimating the leasing value using, if you graze it with about 600-pound heifer. And then if the daily gains, you are charging based on average gain. So they're charging about 60 cents per pound of gain. So if you do that, then the economic value for grazing is about $97. So the total revenue ranges from $511 with the standing cover crop to over $630 per acre for the hay treatment. When you look at the cost, the seeding cost for wheat and sorghum are the same for all treatments. But when you look at cover crop, that is where we have a cost associated with the planting of the cover crop. So that is higher than when you have chem fallow. Then the other thing that we also look at was the herbicide cost, which was more for the fallow treatment because we are spraying more. When you have a cover crop growing, there is no spraying. So if you look at the cost, the variable cost is more for our cover crop treatments compared to the chem fallow. However, if you look at the net revenue, then the net revenue was greater with our graze cover crop treatment, which was about $150 per acre, and then followed by our hay treatment, which was about $80 per acre, and our cover crop standing treatment was actually less than the fallow. And this is because of the cost associated with planting the cover crop and also decreases in yields. So if you use the cover crop as a forage resource, then you are coming ahead in terms of profitability. Then we also look at some of the study on farm. The on farm study, we are looking at only two treatments, grazing versus non-graze cover crops. And these farmers were growing summer cover crops of forage sorghum, German millet, sunflowers, sun hemp, and radishes, or a spring cool season grasses, or winter cover crops of triticale and rapeseed. The stocking rates vary based on producer, and it ranges from 350 pounds to almost 600 pounds live weight per acre. The field sizes that we use were around 40 to 80 acres. So the bottom figure shows one of the field size that we use. This is at Alexander, about 80 acres. We split this field into 4 different paddocks after the cover crops were planted to grazing. So we have a big area where we graze, then the non-graze area is a smaller area where we fence it off from the cattle, and then we allow them access to the area that we want to graze. I think I have a picture that I will show, which will make it a little bit clearer. So this is the picture of the field, an example of a field in Alexander where we graze in the cover crops. Take a look at the middle picture where we're looking at graze and non-graze cover crops. If you can see that we have a polywire fence that separates the graze from the non-graze area. So the cattle are allowed access to the graze area, and then the non-graze area is fenced off using a polywire fence. The first picture is the heifers, they finish grazing, and we're going to move them to the next plot. So the interesting thing is that after you move the cattle to the next block, where you finish grazing, the cover crops will grow back to provide residue cover. This is a picture from one of our summer cover crops on the producer field in Hayes. This cover crops actually takes off. These pictures were taken 1 month apart. We got about an inch of rain for the middle of June, and the cover crops took off. We produced almost about 6,500 pounds per acre. And this was a mixture of sun hemp, Sudan grass, German millet, sunflowers, and radishes and rapeseed. It did really, really well. So this is data from the on-farm study looking at average across the producer fields, looking at cover crop biomass of the non-graze cover crops, and then pre-grazing biomass, and then post-graze, that is the biomass that is left after grazing the cover crop. Even though the non-graze cover crop biomass is always higher, it wasn't significantly different from when we started. And what is interesting is the post-graze biomass was not significantly different from the pre-grazing biomass, which kind of confirmed what we know about these cool season grasses, that they can regrow if you allow some resting period. So after grazing, you allow it to regrow and then provide residue cover. This is some data on grazing days and animal performance, and we measured this on some of the producer fields, and we were able to record gains of about 1.2 to 3 pounds per day. But what is interesting is the number of grazing days. Producers were very excited about being able to rest their pastures because we had grazing days between 30 to 41 days. This is a period that they could rest their perennial pastures when they graze these cover crops. So one thing we were concerned about is soil compaction from grazing these cover crops, and also residue cover and soil organic carbon and aggregate stability. So we monitored this both on our own research and also on the on-farm studies. So this is a picture of cover crop residue after the cover crop were terminated. This is really great. These plots were grazed and then they were terminated sometime around April, and the producer planted grain sorghum into the cover crop stubble. This is data from our research at H.D. Ranch. Here we are looking at residue cover 4 months after the cover crops has been terminated. On the x-axis are cover crop treatments. The first bar is our fallow treatment, which is the check. And then we have standing cover crops, hay cover crop, and graze cover crops. Residue cover was about more than 80% of all our cover crop treatments compared to the check, which was about 60%. So we could graze these cover crops or hay and still have significant residue cover, which is important for our environment. Then we look at bulk density. This is data coming from the producer field in Hayes. We are looking at bulk density at 0 to 2 inch depth and 2 to 6 inch depth. The dark bar is the initial bulk density before we started the experiment in 2019, and the purple bar is the graze treatment, and the not graze treatment is the graze bar. We measure soil bulk density 1 year after we started the study, and there's no difference between our graze and non-graze cover crop treatments. Then we measured it again in 2021. That will be after 2 cycles of cover crops. Here again, we did not see any difference in bulk density between where we graze and where we did not graze. And the interesting thing was that the bulk density of the cover crop treatments was lower than when we started. Then we look at 2 to 6 inch depth, similar story. We did not see any difference in bulk density between the graze and non-graze cover crop treatments, and also the cover crop treatments had lower bulk density than when we started the experiment. Then this is data looking at penetration resistance of the graze and non-graze cover crop treatments. We measured this at Alexander and also in Marquette. At both locations, we did not see any difference in penetration resistance between the graze and then the non-graze plots. Penetration resistance of 2 megapascals is where you begin to see impediments to root growth, and most of our measurements were less than 1. So grading of this cover crop, at least for the short term, did not have any impact on soil compaction. Then we look at soil organic carbon. This is data coming from the same farm in Hayes. Here we are looking at the initial soil organic carbon content when we started was about 1.4%. And in 2020, when we measured this again at the surface, 0 to 2 inch depth, we were close to about 2%. And it wasn't different from the graze and non-graze cover crops, but we were able to increase the soil organic carbon concentration. Similarly, when we look at 2 to 6 inch depth, soil organic carbon increased compared to when we started, and it wasn't different between the graze and non-graze cover crop treatments. This is data coming from our research plots at HB Ranch. This data has actually been published in Agronomy Journal. We look at soil organic carbon stocks in 2020 and 2019. Here we are looking at our 4 treatments: fallow, standing cover crop, hay cover crop, and graze cover crops. And we saw that grazing or haying the cover crop, soil organic carbon stocks in 2019 were not different However, it was greater than the chem fallow treatment. We actually saw an increase of 11% in soil organic carbon content. 2020, we saw a numerical differences, but statistically, it wasn't different from the chem fallow treatment. Then we look at aggregate stability from the same experiment. The first bar is the fallow treatment, and then we have the standing cover crop head and graze cover crop treatment. Aggregate stability statistically was greater with our cover crop treatments compared to the chem fallow. And whether we grazed the cover crop, we hayed or left it as a true cover crop, statistically, aggregate stability was not different. Then we also started a new experiment in 2020 looking at annual forages in dryland crop, grain crop rotation systems. Here we are comparing wheat sorghum fallow, that is the grain production system, versus wheat sorghum fallow, where we graze the stalks of the sorghum. And then we have winter wheat and then sorghum Sudan grass that we plant and then graze. And then we have winter wheat Sudan grass that we hay. So the same kind of approach. These plots are 100 feet by 100 feet wide. So we use the panel to fence them. So the pictures at the bottom shows grazing that we did actually this August. And then we have the grain sorghum that is going to be harvested about next week, and then we graze the grain sorghum stalks. So in terms of some data that we've collected from here, we look at residue cover, aggregate stability, and also soil organic carbon. This is data from residue cover. If you look at this, where we have the grazing of annual forages actually have more residue cover compared to our check treatment, which is the grain production system. However, when we graze the sorghum stalks, we have less residue cover. Then aggregate stability also tend to increase with treatments where we have the grazing of the annual forages or integrating grazing into the cropping system. So in terms of conclusions, we've seen that these cover crops can be very productive, but yields varied from year to year. When we graze the cover crops, so far, about 8 years that we've been doing this, we have not seen any negative impact on soil compaction by measuring bulk density and penetration resistance. We saw an improvement in soil organic carbon content by including the cover crops into the production system. Whether we graze it or we hay it, we did not see any differences, but we saw an improvement over the chem fallow. We also saw an increase in aggregate stability, which is very important for us here for water storage. When we graze the cover crop or we hay it, the soil health benefits were not different. However, residue management is very critical because in our experiments, we are grazing about 40 to 50% of the cover crop biomass. If you graze more than that, possibly you may not see the same results. Our grain yields most often were not different from chem fallow, but we had 3 years where yields were significantly less than the chem fallow treatment. So based on these results, we conclude that using cover crops for forage is a strategy that can improve soil health and also increase the profitability of the overall cropping system. So this is all that I have for you. This project was funded by NRCS. We also have some funding from the Ogallala Aquifer Grant Program, and North Central Sarah Grant also provided some funding for this research. Once again, I'm Augustine Obour. This is my contact information. If you have any questions, I'll be happy to answer them now, or you can shoot me an email if you have any question about grazing cover crops or annual forages to improve soil health. I'll be happy to answer them. Thank you.
Thank you very much. So starting with questions in the room and then you all online, if you have any questions, please type them in the GoToWebinar questions panel in the room. Yes, we have a question.
The question was, what do you see the main barriers preventing adoption of cover crops in a wider scale?
All right, thank you. The question is, what is the main barrier for adoption of cover crops? Yeah, so in our environment, the barrier is just the impact on the subsequent crop yields, because cover crops use water, And then when you grow a crop, after the cover crop, particularly in dry years, you tend to decrease yields. So that is the barrier. So most of the farmers that are now adopting cover crops they are grazing the cover crops to get some economic benefit. And NRCS has kind of modified their recommendations now to allow grazing of cover crop based on some of the data that we have generated. So now people who have livestock are integrating cover crops or adopting cover crops. But for our environment, it's not economical if you don't have livestock to use the cover crop as a forage resource.
Thank you. Any more questions in the room? Yes, Namrata. Or if you wanted me to repeat, it's up to you.
Yep.
There's one more question, and she's coming to us.
Okay.
Hi. Maybe I missed the initial part, but I wanted to ask, like, you showed some slides regarding the net profitability. So I missed that part. So was the profitability higher in standing or grazing or the hay cover crops? Hay one.
All right, thank you. Yeah, so we show some profitability data. So the profitability was higher with the graze cover crop treatment, followed by the hay cover crop treatment. The standing cover crop treatment had less profitability compared to the check, which is our chem fallow. And that is because of the cost associated with growing the cover crop. Now, you plant the cover crop, you have to buy the seed, and then you also have to plant the cover crop. But the fallow treatment doesn't have that. And then your yields on the fallow treatments are greater than your cover crop treatments numerically. So when you multiply the grain prices by the yields, and then since you have extra cost by growing the cover crop, then the profitability is less.
Okay. So those profitability were calculated on the basis of cover crop yields or the yield of the main crops after planting cover crops?
So the question is, how did we calculate this? So we use the income generated from the grain yields from all the treatments. So the grain yields from the cover crop treatments versus the check treatment. And then we also use the cover crop biomass for the non-graze or standing cover crop. There is no income from that, right? So you are using it as a cover crop. But when you hay the cover crop and sell it as a forage, then there's an income from the sale of the hay crop. And then when you graze in the cover crop, there's also an income generated from that. So you have revenue from the graze cover crop and revenue from the hay cover crop. But the standing cover crop, the only revenue is coming from the sale of the grain crops that are planted after the cover crop. Is that clear?
Yeah, it's clear. Thank you.
All right.
Good day. I was going to ask a similar question to Namrata's, but then I have another question in terms of weed management. You recommend planting cover crops to farmers who are trying to restore pastures that have been invaded by the various invasive weeds that are found in America. And is this feasible for large-scale production and like long-term production?
All right, the question is about using cover crops for weed suppression, right? Is that clear? Am I right?
And restoring pastures that have been previously invaded because
Okay, so most of my research is in grain crops, and we when you plant this cover crop, they actually provide weed suppression benefits. So if you look at in our study, any time we plant a cover crop in place of fallow, then we are reducing the amount of herbicides that we apply, and we reduce herbicide application frequency, I think, twice compared to where cover crops were not planted. So in our production system, grain crops is not a perennial system. We grow the cover crop, they provide some weed suppression benefit. And our range scientists here has been doing some work planning. It's not cover crops, but they are annual forages into pastures. They plant warm season grasses into cool season perennial grass, and they are able to get some suppression of weeds. But as to whether it's going to be sustainable is the suppression that we have seen in grain crop production systems. When the cover crop is growing, then it provides suppression. When you terminate the cover crop, then you may have some weeds coming back. So the suppression is short-lived. You can still have weeds coming up, and you have to use herbicides to control weeds after the cover crops are terminated. All right. Any more questions from the audience?
It's more philosophical since I don't know if you can see the audience. There's a lot of students, postdocs, with scholars. So if you have to share a word of wisdom to those who are here today, either doing their grad work or in terms of you are very successful professional. For those who are early on in their career, what that word of wisdom would be? I'm sorry to put you on the spot.
No, that's okay. Yeah, I think from my perspective, you just have to kind of participate in all the research programs that you going through at Hayes. You don't necessarily have to focus on only your research. Get engaged in all the work that is going on, your own research and what your professor is doing, because that helps you to get a lot of experience, get a lot of exposure that will help you in the future. Because I was in Ona, I spent about almost 6 years in Ona. I was driving. So my research is kind of funny. We were looking at water kind of nutrient losses from grazing or pastures in South Florida. And whenever it rains, you have to drive from Gainesville to come to Ona to collect water samples. And I was driving very often during the summer, or I stayed the entire summer. Most of the time, I stayed the entire summer in Ona. It was a lot of hard work, but it was fun doing it. If you understand what you're doing and you like it, you enjoy doing it. And that kind of work that I did in Ona has been very helpful for my success here, because I'm doing applied field research, and I'm also based at a research station, and I like it because of the training that I had in Ona. So take whatever you are doing very serious and participate in all activities, not only on your research. That is what I would say. You will be fine.
Thank you so much, Augustine. I think Andrea is going to say a couple final words, but I appreciate your response. Thank you so much.
Yeah, thank you, Dr. Severia, for the invitation.
Okay, so thank you again for being with us today. And in closing, do you have any final words you might like to say?
Yeah, I think I enjoy my time in Ona, and I miss the place. Unfortunately, when I left, they built a new graduate house, and we were using the old one. So, but it was fun to be in Ona.
Awesome. All right. Well, thank you so much for being with us. And everyone else who is on the webinar, we're going to share a couple of announcements with you all before we actually close off. Okay, so our next ONA highlight is going to be November the 14th, and that is going to be with Dr. Maria Silvera, and she's going to be providing an LTAR research update. So that's long awaited. There's a lot of interest in that, so be sure to connect with us for that. And on October the 28th, there's going to be a pasture walk held in Dade City. And this event is $5 to attend. You can register on site or in advance. And we are just sharing this event as a courtesy. It looks like registration is through Eventbrite. And as always, with all of these events, whenever I send you the recording from today's ONA highlight, I will also share with you these flyers so you can dig in deeper and register for those if you're interested. This event is one that is being hosted a long ways from us, but we're going to share it because it is for ladies and all ladies are welcome, and it is being put on by ladies. It's called Ranch Her. And 3 of these speakers are former Ona students. Juliana Ranches is with Oregon State University, and she's going to be presenting on October 31st. Yep. And then on November 1st, neither one of those ladies were here, but I'm sure those are going to be great talks. On November the 2nd, we have Elizabeth Palmer and Glazy Silva. Both of those ladies were here for a time for their Ph.D. program in completion. So registration for that is online. It is free. And so some great topics going to be covered there. Check into that when I send you that info. This next event is one that's going to be happening nearby at the Archbold Buck Island Ranch and Biological Station. This is a full-day program that will begin at the Biological Station and end at Buck Island Ranch with a swamp buggy tour. Registration is $15, and you'll register with them on their website. So I will be sharing this info with you so you can check it out more closely. So if you're not already doing so, please follow us on social media. We're on Facebook, Twitter, and we have a very active YouTube channel where this video will be posted once we get it uploaded. And if you don't subscribe to our mailing list, every Friday we send out a newsy email with upcoming events or highlights from the week. And so send us an email at ona@ifas.ufl.edu, and we will add you to that list. Again, thank you so much for joining us today, and we hope to see you in November.